So good morning to everybody to this EO4Health user forum. It's one of the many forums we host here at ESRIN. It's on health today. We're very happy to welcome you here. We have a variety of actors and participants from NGOs, from partner organizations that we're working with on health. I see also from industry and academia, so really good to see you all here. I'm Simonetta Cheli. I'm the head of the ESRIN site. I'm the director of Earth observation at ESA, so the one in charge of managing the Earth observation programs, including those on the application and the health activities that you will discuss further today under the lead of my colleague Stefano Ferretti. So having said that, I was asked to briefly introduce you to what the European Space Agency is. I know some of you are aware, some are much less aware of what we do. And ESA is an intergovernmental organization, exists since 75, currently 22 countries, not one-to-one the EU countries, because we also have Norway, Switzerland, and the UK, and we have an agreement with Canada that works in terms of membership. We work on developing technologies, infrastructure, and applications in the field of space. We have an annual budget of about 7 billion euros, and we have more than 5,000 people, both staff and contractors from European and Canadian industries working with us at the agency. Today, just to give you a feeling, the Earth observation budget that I run corresponds to 30% of the yearly annual budget of ESA, so it's about 2.3 billion for 2024. It's the biggest in the agency due to the relevance that is really given in terms of political priorities by our member states to the domain of environment, of climate crisis, meteorology, but also all what is associated to the SDGs, the societal development challenges that we have, and those, of course, include topics like the one you discussed today on health. You're here currently at ESRIN. ESRIN is the establishment in Italy of the European Space Agency. It's known worldwide as the Center for Reference for Earth Observation. It's the place where we basically coordinate all the distribution of the data from our Earth observation missions. We currently have 14 missions in operation, and we are developing over 40 satellites to be launched in the next few years. It's the place where we work in terms of distribution to the users of those data. We archive the data, we do demonstration projects with the science community and user communities like you are, in terms of demonstrating the value and the strategic relevance of using Earth observation data. We also work very closely here on different topics from Earth observation. We have, in fact, a small launcher team, which is located here, which builds the Vega E, the current next generation of small launcher program, and the Space Rider vehicle. We have also corporate functions here at ESRIN, like the security one. As you can imagine, today we are really trying to reinforce all what is related to cybersecurity with ESA programs. We also have the IT function here and a Center for Near Earth Object for planetary defense. But on Earth observation, what I'd like to mention is we host here a science hub with expertise and academic, scientific people coming to work on different topics. We're currently working in that science hub on topics like hydrology of the Mediterranean, also the Antarctic and the Arctic, and some of those, of course, are very relevant for what you discuss here. We also have a PhilLab, a new laboratory of innovation created in 2018. It's a support laboratory to new good ideas coming from startup companies, helping those companies which have new ideas also beyond the traditional space sector to develop products, services, but also technologies related to Earth observation. So those are activities that we run here from ESRIN, and in ESRIN we also run the International Charter on Space and Natural Disaster. It's something that we do with 17 space agencies worldwide, many European, but also Japanese, American, Chinese, and Indians, and many more, that put together available in-kind data from the missions whenever there is a natural disaster happening in the world. And this is a secretariat which is hosted here at ESRIN. Overall, at this site, you have about 50,000 visitors per year, pre-COVID numbers. We went back to 30,000 end of last year. People that come like you for workshops like the today one, science visitors, also industry that come for the reviews, workshops, of course, but also decision makers. We had this morning a visit from EFCA, for example, the Fishery Maritime Agency of the Union, and of course, general public. Here you see the remit of the missions that we work on. I just told you we have 40 missions in operation. We have about over 40 in development on 3 lines. The meteorological mission with EUMETSAT, we have launched the first meteorological mission at ESA in 78. We just launched about more than a year ago with EUMETSAT the new generation of meteorological third generation mission, MTGI. It's now becoming fully operational with the nowcasting capabilities over Europe and Africa, and instrument to forecast at best hurricane events and extreme weather events. So that meteorological line of missions is enhanced. We'll launch this year an Arctic weather mission, a dedicated satellite mission that will be followed by a constellation by EUMETSAT. We have the Copernicus Sentinels. Those are missions in the context of the led European Union program Copernicus. We have a few Sentinels up and running. Many of those are extremely relevant for the topic of health, because you have Sentinel-2 optical radar, Sentinel-1 5P to monitor all what is related to atmosphere quality, and also see temperature, land temperature with Sentinel-3, for example. Many more to be launched in the coming years, including dedicated CO2 monitoring mission for looking at anthropogenic emission in the context of the COP agreements. And last but not least, we have some missions which are scientific. Those are called Explorer. And in that context, we have missions, for example, on soil moisture and also salinity. There again, missions that are extremely relevant in the context you're discussing for assessing increased desertification, droughts, and all things that can have an impact on daily lives, and of course on agriculture planning, on things that of course have implication in terms of societal benefits, but also in terms of what you're discussing here today. The challenge we have currently is that we have many missions, many satellites, and increased number of available data. With a free and open data policy, which of course is extremely relevant for partners like those here in the room today. I know there is the Ministero de la Salute here, but also WHO, with whom we have already since a few years an agreement. FAO, we have an agreement already with FAO on agriculture that we hope to extend to the health domain in the near future. And of course, we have a discussion with WOA in terms of discussing an arrangement. And all these data are available for partners like you represent here today in the room in terms of usage for your needs and application and requirements. We work with available 350 terabytes of data from Sentinels per day. So you see, and the number of users has increased. We are today at currently registered users of 750,000. And this is steadily increasing every month, and it shows the success of Copernicus. We're supporting the 6 operational services that are managed by the European Commission: the marine, the disaster, the security, the ocean, land and atmosphere, and climate one. And we do that in terms of supporting with data provision from the current Sentinels, but also contributing data from national missions and commercial data missions that are available. You see here basically the observation, the resolution, and the timeliness of such data from Sentinels, which, as I said, are complemented by many more in terms of ESA having an advice role to support the services, but also ESA putting together the data packages to serve those user community. I mentioned you the disaster charter. This is a mechanism that is coordinated via secretariat that is hosted permanently here at ESRIN, but it's the collective work of 17 space agencies worldwide who have Earth observation mission and data to provide and put in common whenever there is a natural disaster happening. Can be earthquake, can be flooding, can be volcano eruptions. And I'm sure the charter has been activated yesterday for Iceland events, and I didn't get the messaging. I'm not anymore in that mailing list, but we basically have an activation of that charter mechanism, which is a provision to support anybody anywhere in the world through an activation by civil protection or NGOs or even UN agencies whenever there is a disaster. And we put at the disposal in a turn mode of rotation with the various agencies, products and services on the website, which are available basically in a matter of few hours to those who need to get them. The PhilLab I mentioned is really an interesting mechanism of working. It's an innovation laboratory where we can develop also demonstration projects in terms of new products and services with startup, but also with companies working in the traditional value-added sector. I see some here in the room. I see Ersk, who represents many of those value-added sector, but I also see Nereus representing the Committee of the Regions, with whom we have long-lasting collaboration in terms of demonstrating for users which are non-space users, but which are local authorities or which are, users from the non-space sector, that you are really demonstration project that can be started also through the PhilLab and through the collaboration with the teams of Stefano and what they do in EO4Health. So that's another interesting mechanism that we have. Last but not least, as I said, the challenge is the increasing available number of data, giving data to users in time, in quality, and on a continuous basis. And that's exactly what we try to do with our programs. And we have been progressively integrating more and more digital technologies into our daily work. We have done this through a collaboration, a very strong one with the European Union on a program called Destiny for integrating the data available into forecasting models and prediction models with ECMWF and EUMETSAT. And we also have the complementary corresponding R&D activity in ESA to develop a dashboard, which is a unique buy between the two programs on forecasting capabilities. What if, with evolution assessment that can be useful for decision maker. And I think that's one that you should look at also, because what if it's particularly impactful if you look at the domain of health, where you need to know what will happen in case the temperature will increase. We just saw WMO report during the weekend, hottest ever assessed year 2023 ever in history. And this was also thank you to ESA data, which are the science ones, but also the Copernicus one, which have helped to look at sea increase of temperatures, but also land temperature increase over the last year. We work very closely with the UNFCCC, with the COP context. I was in Dubai with the teams managing a program which is called Climate Space. I'm going tomorrow to EXAT, where we have this team in ESA managing the science climate activities, and we support over half of the climate variables, which are the indicators in the context of UNFCCC, the information related to ice melting, sea level rise, atmosphere quality. And this is very relevant again for health. You know that the European Environment Agency has given indication of over 450,000 deaths in Europe alone in terms of the impact of the air quality. A lot of that can be done and monitored through the satellites that we have available, including, for example, Sentinel-5P, and this will become more and more relevant in the future. Here you see, in fact, beyond the European remit, that we work to support the SDGs since 2015. More than 10 of the 17 SDGs are supported at the UN level with satellite data. Just to give you an example, not only we work on climate and food security, but we also work actively on water resource management with UNEP, where we look at the evolution of water basins, and we have a lot of methodologies to share on that. UNFCCC, I mentioned, we support the climate variable. The SABSTA collaboration is very close, and UNFCCC last report, the one that was published in March this year, has really increased the number of satellite data sources that were associated to the monitoring of the climate variables. In Europe, we have a very strong collaboration with DG Clima. We just confirmed it recently. We will support the monitoring of the implementation of all legislation of DG Clima in terms of Fit to 55, particularly in the domain of greenhouse gases, LULUCF, RED Plus activities. And of course, we have a lot of collaboration with the environmental UN conventions since the year 2000 when they were started, 2002, I think, when they were started, and we were recently at the biological diversity convention, the biodiversity one. We work on the Ramsar convention on the humidity. So those collaborations are all to demonstrate the value of what we do in terms of exploitation of the data. You have here a few examples because you'll go much more in depth into the discussion of what's related to health, but we support environmental security. Here you have alerts on the Congo Basin. You have what you can do in terms of looking at deforestation of a period of times. We work, for example, also with UNESCO in terms of heritage data to look at what is available in terms of forest and food for gorillas in special habitats. These are just many examples of application that we've developed during the years through our program. Food security, certainly it's a very relevant one. We were an active partner at the recent FAO food security meeting last July. We do crop estimates through satellite data. We do classification of land cover. We also have done yield crop estimates, continuing the work we've been doing on Ukraine after the start of the war, supporting those data that were coming from international partner organizations like OECD, estimating the crop production, very relevant in terms of also economic value. We can also, and we have supported for the last 30 years, the COP agriculture monitoring in terms of looking at statistic, land use, support to monitoring the implementation of the legislation. And all of this is now combined with the support in terms of having information tools to see if you do reduction of pesticides, for example, the impact in terms of CO2 and green agenda activities. So a lot can be done in that domain apart from food security, but in the agriculture domain overall. And as you see here, we can improve agriculture statistics from a country to a field scale. We have a VOLD cereal program that has been recently kicked off, and all those mechanisms are managed by the teams here in Esrin with, of course, industry and experts worldwide. Another example is the support of SDG 6, the ecosystem. I mentioned you the changes in surface water extent, river discharge, and all this is done in very close collaboration with UNEP, who leads the on the side of the UN agencies, all the work which is done on 661, so the water management activities in the context of the SDG. And you can see here that you can do modeling, but you can do monthly occurrences. You can look at the water basin evolution. This we do in Africa, of course, but in many areas of the world. And all of that, of course, it's also combined with some more specific work on health. I'll just have this slide to say and mention that we recently got an award through a colleague that was working on health activities, integrating AI technologies at the PhilLab on an UNESCO project, and looking with UNICEF at a collaboration on research activities and humanitarian work on malaria mapping. And this was something which is a demonstration on, no, this was on the dengue outbreak, so it was not on the malaria. On that one, we got the specific award from UNICEF, where we made the integration of artificial intelligence technologies into basically a domain which is the health one that you are the one that you're concerned in. Dengue, of course, it's big concern and big risk, not only in some areas like Peru, as you see here, but we launched from French Guiana. Dengue is very present in French Guiana, so it's a daily issue that we also face at ESA. Here you see the malaria example. Yes, here you see how we use Sentinel-1, Sentinel-2, and Sentinel-3 mission combined. And this is also another strength of the EU data value, combining different data sources to support, I would say, what is the estimate in terms of spreading of malaria dynamics and diseases. We've also worked in support of some specific COVID-related activities in Africa through Charter of Disaster. So something which is related to basically estimate forecasting models, but also monitoring of activities related to support specifically in some region can be done with satellites data. We have a very, very, I would say, complex value chain here, but just to give you the feeling that we are actively working from the organization of dedicated products, which are products that are tailored to specific user community, like the one you represent here today on health. We do onboard processing because it's part of our DNA to demonstrate the value of new innovation technology in our work. We have to support with processing capability, with digital twins for forecasting. We do use different platforms, and we use multi-platform observation. And we, of course, try to connect as much as possible the world, which is the one of ground and space system, with the satellite world that we represent. So that's a very synthetic, I would say, snapshot of the world we work in terms of trying to support in an increased way with all the tools we have, the societal issues that we face. And I'll stop here because I'm sure you'll have much more in-depth debate during the morning. And I thank Stefano for organizing this session and you for participating today. Thanks a lot.